Hi everyone, myself Pankaj and welcome to the new video of solving most important DSA interview questions. So in this video, we are going to solve another graph problem and the name of the problem is clone graph. So this is very tricky problem and let's say how we will use our logic to solve this problem. So let's read the problem statement. So you are given a reference of a node in a connected undirected graph. Return a deep copy of the graph. So basically you are given with an undirected graph and you have to clone it, right? And what is deep copy? So we will basically see it after. So you can see that each node in the graph contains a value and a list. List is basically a vector also, right, of its neighbor. So basically what it's saying that for a node, the node will have a value val and each node will have a list of neighbors, right? And the test cases formats are basically for simplicity, each node's value is the same as the node's index, for example. So let's understand this question properly. So I am taking this example, the first one, right? So let's come here. So you will be given with this adjacency list, right? And so this adjacency list is basically representing the adjacent nodes of the graph, of the nodes of the given graph. So where are the nodes? You must be thinking, right? So in the question they have given that. So basically, the indexing is of this adjacency list is basically starting with 1. So this is at 1 index, this is index 2, this is index 3, and this is index 4. So what does it mean? So it's mean that this is node 1, this is node 2, this is node 3, and this is node 4. And for these nodes, their corresponding neighbors are given. Basically, the list of neighbors. So okay, so let me make them down here. So for node 1, this is its list of neighbors. For node 2, this is the list of neighbors. For node 3, this is the list of its neighbor. And for node 4, this is the list of this neighbor. So I hope you have understood this input format that they have given in the problem statement. So now what you have to do? First of all, let's construct the the graph out of this. So there are 4 nodes, right? So let's construct the graph. So let's call it as first node. This is second node, this is third, and this is fourth, right? So let's name them out. So this is node 1, this is node 2, this is node 3, and this is node 4, right? Okay, let me delete so let me remove them first here. First of all, let's say we have created this node 1, right? So node 1 has 2 neighbors. You can see here node 2 and 4 are its neighbor. So where are 2? So this is 2 its neighbor, and 4 is also neighbor of 1. So we created this, right? Now when you come to node 2, you can see here 1 and 3 are neighbor. So for node 2 we have already created its neighbor 1 and we have to create neighbor 3. So here is 3 that we have created the neighbor of node 2. Now when we came to node 2, its neighbor is basically 2 and 4. So for node 3, the neighbor is 2 and the neighbor is 4. So we have created this out, right? For node 4, the neighbors are 1 and 3. For node 4, the neighbor is 1 and 3. So we have already created this, right? So this is the graph that you are getting, right? And this is undirected graph. So basically you have to connect this out in this manner, right? So this is undirected graph. So this is the graph that we are getting after utilizing the input variables that we are given with, right? Okay. So now what they have given in the question that we have to create the deep copy of this graph. So what does the deep copy means? So let's say this node this node is stored at a memory space X, in the memory at position, let's say X, right? So when you will create a copy of this node 1, what we will do? We will create another different node with value 1 and it should have some memory space, address of the memory space, let's say Y. So in this manner, this node 1 and this node 1 are called as different nodes. Why? Because their memory address is different, right? If they had stored at the same memory space, so that node would have been same. That would not be the deep copy. You can say it as a shallow copy, right? So you have to make a clone of this graph so that we can using so you have to make the clone of this graph using deep copy, right? So for every node you will be having a deep copy of each node, right? So you will create a node 2 here, let's say node 2, and its address maybe, let's say it was at address P, so let's say it is at address V, so its address must be different from V, so let's say address at O, right? So in this manner you have to create the copy of this graph, right? And after creating the copy, so the graph will look like similar to this. Okay, okay, let me remove this first. So after creating the copy, your graph will look like this, right? Similar graph, right? So you can see here in the example that they have given here, this is also like the copy of the graph, but you are returning the same graph, so you don't have to return the same graph. Or here they have also provided another graph. So this is the, here they have given a description here that the node were cloned. Here you have cloned the node, right? In this graph you have cloned the node, but what you are doing, you have basically reshuffled the nodes, right? Here the node should be 2, but you are actually giving 3, so this is also not right graph, right? And in the above graph we have basically returned the same graph, so you don't have to do that also, right? And this is the right one graph. Why? Because each node are different. What does it mean? It means that they are at different address of the memory, right? So that's why we are returning that. Now how you will use this, uh, so how you will apply your logic to solve this problem? So how we will solve this out? So basically, for most of the graph question, we use two traverses, basically DFS and BFS, right? So for making the copy of each nodes of this graph, so what you have to do, you will first have to traverse this graph and go to each node, right? So you will have to go to each node and then clone this node, right? And at the end, what you will do, you will basically connect them, right? So but in the answer output, what you have to return, you have to return in the same manner that they have given the input, right? So basically you have to return the new neighbors of the cloned node, right? Let's say you clone this node, right? And the neighbor of this node 1 is 2 and 4, so you have to store these 2 and 4 inside the vector, inside a vector. When you come to node 2, you have to clone this node and you have to store its neighbor inside another vector. So these are 3 and 1 are the neighbor of node 2. So what you will do, you will create another vector and you will store its neighbors, right? So in the same manner you will do the same for all the nodes, and you will store them inside, let's say, in this manner, right? So you will store all the values inside the vectors, all the neighbors of each node inside vectors, and you will return that, right? And the type of this vector will be of node star. What does it mean? That you have to return it as a what? Graph, or you can say as a pointer, you can say, right? So here you can see that inside its definition of a node, what they have given, they have a integer value val, which will represent the value of the node, and there is a vector node, a vector that is called as neighbors. Its type is basically node star. What does it mean? It's basically storing the address of each node, right? And so it's basically representing the vector of neighbors, right? So how we will solve this question? So what I said, that you will have to traverse this graph or go to each node. You will traverse it out. So first of all, you will have to traverse this graph. You will go to each node, and for each node, what you will do? You will create a vector of its neighbors, right? You will create a vector of its neighbor, and let's say if you have already cloned that node. So let's understand this in a simple manner. So let's say you are currently at node 1, right? And you when you are at node 1, so first of all what you will do, you will clone this out. So you clone this out, right? You clone this out, then what you will do, you will go to its neighbor. So what is the neighbor of node 1? So basically neighbor of node 1 is uh, 2 and 4. You can see here in the input that we are given with, right? So what you will do, you will again clone, you will again go to node 2. Now your, okay, let me erase this. So currently you were at this node 1. So you cloned this out. So you saw that the neighbor of node 1 is 2. So what you will do? You will go to, what you will do? You will go to node 2. So we have not cloned this node 2. So what you will do? You will clone this node 2 with value 2, right? Now you will check the neighbor of node 2. So neighbor of node 2 is basically 1 and 3. So let's say for instance, uh, For instance, we came to node 3, right? We could have also gone to node 1, but let's say we came to node 3. So at 3 we saw that 3 has not been cloned. So what we will do, we will basically clone this node 3 with value 3, right? Now we will again check the neighbor of node 3. So what are the neighbor of node 3? So 2 and 4 are the neighbor of node 3. So let's say we went to node 4. Okay, so let me delete this out. So let's say you came to node 4 and you saw that node 4 has not been cloned. So you will clone this node 4, and again you will check what are the neighbors of node 4. So you saw that the neighbors of node 4 is basically 1 and 3, but you saw that the neighbor of 4 is 1 and 3, but you can see that we have already cloned 1 and 3. So but node 4 does not know that whether 1 and 3 has been cloned. So what it will do, it will basically create another node with 1. So we don't have to do this, right? So what does it mean? That we have to keep track which nodes has been cloned already, right? So for this, what you will do, we will basically use a map. So let's say this is the map. We will basically use a map for checking whether for storing whether whether a particular node has been cloned or not. So let's say we were at node 1, right? So for node 1, inside our map nothing will be there, right? But when we will initialize our function call, when we will come to node 1, we will first check whether node 1 has a clone or not. If it does not have a clone, so you can see that initially it has nothing. So we will clone this out and store this cloned node inside this node, inside this map, right, corresponding to that node, right? So for 1 we stored its cloned value, right? Now when you came to node 2, you will again check whether this node 2 has been cloned or not. So you can check this inside your map. So initially there was nothing cloned with 2. So we will clone this out and store that cloned node corresponding to that node, right? Again we will do same for node 3. We will store its cloned value. For 4 also, right? We will store its cloned value, right? Now the condition when we were at node 4 and we saw that 1 and 3 has already been cloned. So in that case, what we will do, we will basically we will not clone that node, right? So this case will be handled in this, right? So this case will be handled in this, right? So we will not clone this again, right? So we will handle this using a map data structure, right? Now I had said you that for each node you have to return its neighbor. You can see for node 1, basically the cloned node, that so basically this is cloned node, right? We don't have to return this out. We have to return its neighbor inside a vector. So we will use another data structure, let's say temporary data structure neighbor, or you can say adjacent neighbors, right? And inside that vector we will store these 2 and 4 corresponding to this node 1, right? For node 2, and again I am telling you, for each node there will be a different neighbor vector, right? You can see here for node 1, this neighbor vector is unique, right? This neighbor vector is unique. For node 2, this neighbor vector is unique. For node 3, this neighbor vector is unique, right? In the similar manner, for this node, cloned node, right? For this cloned node 1, we will use a different vector for its neighbor for 2 and 4, right? For node 2, we will again use a different vector for storing its neighbor, that is 1 and 3. For node 3, we will again use different vector for storing its neighbor 2 and 4, right? In the similar manner for 4 also, right? So this is the logic of this problem. So this is the logic for solving this problem. And as I said that for traversing our graph, I will basically use DFS. So you can use DFS and BFS both, but since the DFS code is simple, that's why I'm going to use DFS, right? So let's see the code of this problem. So first of all, what I had said you that you will have to a map data structure for checking whether we have already cloned that node or not. So we will use unordered map for that, right? Unordered map. The type of map will be node star. Why? Because we are going to work with node. So basically we will store the address of that cloned node, right? Let's say we call it as MP, right? Now we will use a base case here. Let's say if your initial node is already null. So what does it mean? It means that there is nothing inside your graph. So what you will return? You will basically return null, because you don't, since there is no node, you don't have to create any copy. So you will again return what? Null also, right? return basically null, right? Now the another base case will be, let's say you have only single node here, right? You have only single node. So in this case, what you will do, you will basically return an node with no value. You can see here we are basically, since the adjacency list is empty. Why? Because this node 1 has no neighbors. That's why the adjacency list is empty. So we will basically have to return a graph with no neighbor, right? But this graph should also be cloned value, right? We don't have to return the given graph. So for that we will clone it actually. So for checking the condition, let's say what it will be the condition, if node neighbor. So how I am able to use this node neighbor? It's representing the neighbor. Why? Because in the definition of this class, you can see that uh, here we are given with that there is a vector called neighbors, right? Neighbors. So what does it mean when you declare vector of type node which have same name as the class? So it's basically, this class is basically called as a referential class. So whenever you will create an object, right, so that object will be able to reference another object. So in the same manner we are using this nodes neighbor. So in our previous questions, if you saw the definition of the nodes in the class, so we were basically seeing what uh, that definition was like node star left and node star right. So when we create pointers with the name same as the class name, so this class is basically called as referential class. And whenever you will create an object of this class, so you will basically will be able to reference another object with this pointer left and right. In the same manner, they have given this neighbor vector. So we will check this if node neighbors. So node neighbors is basically a list, or you can say vector. So if node neighbors dot size is equal to 0, right? So it means that there are no neighbors of a particular node of the given graph, or you can say a single node graph. So in that case, what you will do, you will create the clone of that single graph and you will return the neighbors which are basically there is nothing, right? So what you will do, you will first create let's say you call it as clone of that node. So for creating a clone, you will use new node, and the value of that node will be what? Node val, that current node value, right? And what you will do, since you have created this node, you will clone node, so you will return this clone, right? So we are returning that clone node, and basically that the neighbor of that clone node is basically nothing. We have nothing in its neighbor, right? So it will be empty, right? Now our main function execution will start. So let's say we were at node 1, so we will start executing our DFS call from node 1. So let's say we call it as DFS, and we will pass the node and map for checking that whether we have cloned any node or not, right? So the type of this DFS function will be node type DFS, and we have passed this passed the current node. Let's call it as current, right? And we have also passed unordered map. So let's copy this out, and we will have to pass it as a reference, right? So that no copy is created. So we will use ampersand for that. So now we are here, right? So for each node, what I had said you that we have to create a different vector for each node. Why creating a different vector for each node? For storing its neighbor value. For 1, we will use a different vector for storing 2 and 4. For 2, we will use another vector for storing 3 and 1. In this manner, right? In this manner that they have provided in the input format, right? For node 1, we will use this vector. For node 2, we will use this vector. So first of all, let's say we were at 1. So what you will do, node 1, for node 1, what you will do, you will create a vector to store its neighbor. So and the type of the vector will be basically node star for storing the address, right? So what you will call it, let's call it as neighbor vector, right? So let's call it as neighbor vector. Now since you have created a neighbor vector, so what you will do, let's say you were at node 1. So first of all, you will clone that out node, right? So let's call it as clone is equal to new node with the value will be current node value, right? So you clone that node, right? Now, since you have cloned that node, so you will have to make an entry inside your map that for node 1 we have cloned that node 1, right? So what you will do, you will basically corresponding to your current node, but you will store your cloned node, right? Now we will have to traverse its go to its neighbor, right? Since we created node 1, since we have cloned node 1, we will go to its neighbor, right? And do the same function call similar to what we have done for node 1, right? So let's call it as auto ampersand x of what? Current neighbors. So we will traverse the current node neighbor vector. So this is representing the neighbor vector, right? So what I'm saying that this was node 1 neighbor. So we will traverse this neighbor, right? And what we will do, we will first check whether this neighbor, whether we have cloned this neighbor or not. So what will come here? So it will basically, we will use mp dot find function for checking whether it is already cloned or not. So let's say we have, if we don't find mp dot end. So this statement is basically saying that if we don't find that clone node inside your map, so in that case what you will do, you will basically, so no, I'm sorry. So this is basically saying that you have already cloned that node. So this statement is basically means that you have already cloned that node. So what you will do in that case, you will have to basically push that node inside your neighbor vector, right? So let's say I have already cloned when we are at, let's say when you are at node 2, let's say when you are at node 2, so its neighbor are basically 1 and 3, but you have already cloned node 1, so you will not clone it again, but what you will do, you will push this node 1, that is cloned one, inside the vector neighbor vector of this node 2, right? So that is we are doing here. We will basically, let's copy this vector dot push back what, x, right? Sorry, actually we are pushing the original one, we have to push the cloned one, right? mp of x, right? Now we will, if that is not the case, so it means that we have not cloned that node. So in that case what we will do, we will again call this dfs call for that node, right? So dfs call will be basically like this, dfs of what, x comma mp you will pass as parameter, and when it will return, so we will have to push that value inside your neighbor vector of that neighbor, right? Control plus b dot push back. Okay, so right, you pushed it out, right? So at the end, let's say at the end, let's say you were at 4 at the end. So at the end, all its neighbor has already been cloned. Let's say 1 and 3 has already been cloned. So what you will do, you will come out of this loop that these two conditions are not satisfying. You will come out of this loop, and what we will do, you will basically what, against this cloned node, that is 4, right? You will store your neighbor vector, right? And you will return back to 3. So again, the neighbors of this, all the neighbors of this node 3 has already been cloned. So against this cloned 3, you will store your uh, cloned nodes, right? That are cloned neighbors, that is 4 and 2. So we will have to, at the return time, we will have to what, against that cloned node that we have cloned here, you can see here we have cloned, against that clone node you have to basically store the neighbor. So the neighbor of that clone will be GHBOURS. So neighbor will be what, that neighbor vector, right? And basically will what we will do, you will basically return the clone. So this is the code of this problem. So let's try to submit this out for the public test cases. Okay, neighbors in node did not mean neighbors. NEIGHBOURS. Okay, so we are using, Okay, let me copy this. I have done some mistake. Neightbors. So it's spell. I have given the wrong spelling. Okay, never where I control plus V again here. Use now it's right, I think. So let's try to run this out again. So you can see that our public test cases are passing. So let's try to submit this out. So you can see here our code has been accepted. So this was the I think a tricky question, and if you didn't get this logic, so first of all you dry run this code on your paper, right? So after that you will be definitely able to uh, get the logic of this solution, right? And you must be remembering that we for each cloned node we are actually creating a neighbor vector. So when you will dry run your code, you will actually get it out, right, how it's working. So this was all about in this video. So let's meet in the next video. Till then, have a nice day.